In this video, I will demonstrate how to use CompositePro to support a finite element analysis of a composite structure. So oftentimes as engineers we don't have lamina or ply level material data sets, and we have from a manufacturer we have a fiber material data set and a bulk resin material data set. So we can use CompositePro to arrive at ply level or a lamina data set using the new item, new lamina from Micromechanics tool. And using this tool we can select a fiber and matrix property that comes pre-stored with CompositePro, or we can create a new fiber and matrix data set from our manufacturing data and select that data. So for this example I'll select an S2 fiberglass and a 5505 epoxy, and I'll say that the fiber volume fraction is 59%. So when I click on calculate, I get a set of lamina properties for my glass epoxy lamina. So I can save this lamina and I'll name it glass epoxy demo. And now most FEA solvers have what's referred to as layered elements now, where you can specify an individual lamina or an individual ply material data set like we have here, and then you can build your composite laminate inside the FEA package. However, some FEA solvers don't have this capability and will need to specify the orthotropic material properties for a full composite laminate. Now we can arrive at that using CompositePro by going to Laminate, Laminate Engineering Properties. So here's where I can build my composite laminate. And I will use a thickness angle template that I can find clicking on the library button. And I will select a 1080-10 glass epoxy template, and I will use the lamina we just created, the glass epoxy demo. And here I have a fully populated composite laminate. Now I can save this laminate. I'll name it Laminate Demo. And when I click on the Properties tab, I can select Calculate Laminate Properties, and I can get a set of orthotropic material properties to assign to a shell element. I can use the 2D properties, and for a three-dimensional solid element I can use the 3D properties. Another way we can use CompositePro is to get a more in-depth understanding of the complex failure modes that are oftentimes associated with composite structures. A common example of this is when in the finite element model we use two-dimensional shell elements to model a composite sandwich panel. Now, composite sandwich panels by their nature have very complex failure modes, especially in compression. So we can use CompositePro to investigate these complex failure modes. So to do this I can select the Sandwich tab and click on Stability. And here I can open the laminate demo that we've already created. And on the Sandwich Geometry tab I can enter the width, let's go with 25 inches, and length of my sandwich panel, and then also the core thickness. I'll go with 1/4 inch. And then from the core type drop down menu I can select one of the cores that come pre-stored with CompositePro, or just like for fibers, matrix, or laminas, I can create a new core based on the manufacturing datasheet. So for this example I'll select an aluminum honeycomb core, and then on the Calculate tab I can select the boundary conditions that are associated with my composite sandwich panel. In this case I can select from all edges simply supported, all edges clamped, or a combination of the two, and I'll select all edges clamped. And after I click on Calculate, I will get a list of the compressive stresses that will cause these more complex failure modes in my sandwich panel. So what I have here is the core shear instability critical compressive stress. This is the stress that will cause my sandwich panel to fail, the core to fail due to transverse shear. And then I also have the compressive stresses that will cause my sandwich panel to fail due to face wrinkling or due to face dimpling. Another common example when conducting a finite element analysis of composite structures is how to determine the buckling loads of, let's say, a composite column that's used to reinforce a composite structure that's being loaded in compression. So in this case, unless we run a geometrically nonlinear analysis in our finite element solver, we really don't have a good understanding of the buckling loads when applied to our structure that will cause our composite columns to fail. So we can use CompositePro to get a more accurate understanding of when our composite columns will buckle. So to do this, we can click on Tube Beam, Column Stability, and again we can open our laminate demo, and then on the Tube Geometry tab we can select from a number of section cross sections for our composite column. I'll choose C-section, and let's say our C-section is 2 by 2. First, I can click on View Section Properties to get an overview of the section properties associated with my composite C-section. And then on the Calculate tab, I can select the load or boundary condition that's being applied to my composite column. So in this case, I'll say it's a point load that's applied to a fixed simple boundary condition. And I'll say the length of my composite column is 60 inches. So by clicking on Calculate, and I will see the critical load and critical stress applied in compression that will cause my column to buckle. So this was just a few examples of the tools available in CompositePro to support a finite element analysis of a composite structure. If you have any further questions, you can contact us at info@firehole.com.